that again. Good morning, good evening, good afternoon, depending on where you are. Hello and welcome to Rajant's Industrial Automation and Tele-Remote Machine Operation webinar. My name's Bernard Taliaferro. I'm the Vice President of Global Channels here at Rajant, and I have the honor of being your host for this webinar today. A couple of housekeeping topics to go over first. First off, please be aware that the webinar is being recorded and it will be archived and posted to our partner portal, allowing you and others to view it at a later time, at your convenience. I also want to point out that we currently have everyone's line muted except for the presenters. If you have any questions, please type them in the chat window. You can open the chat window by clicking down at the bottom of the screen where it says chat. You can open up that window. You can type your questions in there. And we'll have 2 question and answer sessions during the webinar. So I'll be keeping my eye on that chat box, and I will actually call on you by name during the question and answer session and ask you to ask your question live, and our presenters will answer the questions live. So that's it for the housekeeping topics. So allow me to introduce our speakers for today. So we have Mr. Stephen Griggs and Mr. Carl Finter with us today. Stephen's the Vice President of the Sales Engineering team here at Rajant. Stephen's been with Rajant since 2007. He was actually our first application sales engineer. Stephen's got well over 20 years of professional design, project management, on-site field work, product management, and technical training experience. And he leads the sales engineering team for Rajant. Carl Finter is Rajant's Sales Engineering Director for the Europe, Middle East, and Africa region, so the EMEA region. Carl's worked in various business development, project management, pre-sales, and technical training roles in his 20-plus years career. He's been with Rajant now for almost 8 years. And again, he's oversees sales engineering and also our training program, so sales engineering for the EMEA region, and he also heads up the partner training program. So without further ado, I'm going to turn things over to Carl to start, as he'll run through the agenda and go through the first half of our presentation for the day. Carl, it's all you.
Thank you, Bernard. Good morning, good afternoon, and good evening, everyone. Just once again, I notice people keep on unmuting themselves, and just to keep it pleasurable for everyone, please make sure you keep yourself muted. It won't interrupt the flow of the webinar. So the primary aim of this webinar is to make partners aware of the use cases in industrial automation and tele-op-assisted machine autonomy, but also highlight some key requirements and the help guides and the resources available to partners to design and optimize kinetic mesh for use in these use cases. So the first half of this webinar will focus on industrial automation. We'll provide some context on PLCs and how PLCs are used in process control. We will then provide an overview of the relevant help guide that we've created for this specific use case, and then discuss some novel use cases for illustration. And this will be followed by a QA session covering this first half, questions on the topics covered in the first half of the webinar. I'll then be handing over to Stephen for the second half. We'll provide an overview of the tele-op and assisted autonomy machine solution market. And Stephen will then go ahead and highlight some of the various important topics covered in the tele-op and autonomous help guide for kinetic mesh. And right at the end, Stephen will summarize lessons learned today and end with a final QA session covering the second half of the webinar. So just for context, just for an introduction, we to start off, we've seen in the past decade, the past 10 years, we've seen a steady increase in various application network requirements. And that includes an ever-growing demand for network latency and jitter, or lower latency and jitter, an ever-increasing demand for higher average throughput. Now, Kinetic Mesh is continuously being enhanced for these applications. We continuously develop our rich config optimization feature set, and we also consistently develop new products and new product features to address these demands. However, one of the key takeaways today we want to teach partners to look out for is understanding your application's network performance requirement. This is a topic that will come up over and over in today's session, and you'll see this gets covered in a lot of the training material as well. It's not a good idea, and it's unfortunately very common today to see people approaching an opportunity or a new design or a requirement and then just simply selecting hardware when they don't really understand the application requirements. So we're focusing on some key metrics, network metrics and performance metrics that you need to be aware of to understand the impact on product selection, network design, etc. So we continue creating various help guides. We'll mention at least maybe three of them in today's webinar. And we'll repeat this. Be aware that these guides are already available at both channel.rajant.com as well as secure.rajant.com. Both of those portals already have those help guides available. So jumping in on the topic of industrial automation. So if we define what we view or what we see as industrial automation, it is simply applying technology to reduce human intervention in industrial processes by automating the control of electrical and mechanical functions. That's what we refer to when we talk about industrial automation. Now, a good example, a primary example of this is the usage of PLCs for process control and monitoring. Now, during the previous webinar, I made the assumption that most of the audience will understand what a PLC is, and we had questions during the QA session. So just by definition, and this is for the PLC engineers among you, I might commit a sin now, but I'm going to simplify the definition. A PLC stands for Programmable Logic Controller. It's essentially a ruggedized computer controller used to control various electrical, mechanical subsystems and processes in a industrial process environment. This might be motor speed controllers, actuators, sensors of various types. It can be hundreds of different subsystems and devices that fall into these categories. And a PLC takes control of that. And PLCs can be deployed in various logical layouts, master and slave configuration, or in various formats to monitor and control these various subsystems, what we refer to as I/O, PLC I/O subsystems. So PLC control is a very good and a solid example that we want to focus on today in the process control and monitoring environment. Now, modern PLC systems can use Ethernet networks to communicate, and these Ethernet the Ethernet communication often makes use of what we refer to as an Ethernet-based field bus protocol. These PLCs have some of them have their own Ethernet-based field bus protocols used for communicating with these subsystems over an Ethernet-based industrial network. And on screen, there's some examples of this. Profinet, which is a standard which is handled by the Profibus and Profinet International Organization. EtherCAT, which is handled by the EtherCAT Technology Group, and then the Ethernet/IP field bus protocol, which is handled by the ODVA Association. Now, just to be clear on that last one, that Ethernet IP referred to there does not refer to the generic Ethernet 802.3 standard or the IP protocol stack. That specific reference there is to a patented field bus protocol referred to as Ethernet/IP, and you can see how they denote it on the screen there. And that specific protocol is managed by the ODVA organization. Now, of these Ethernet-based field bus protocols, Profinet is an extremely common and popular choice. We see it a lot, so much so that we've actually created a guide which we'll go through today. Now, this guide is applicable to some other process control and industrial automation environments as well, but the guide focuses on Profinet, because it's extremely popular. Now, Profinet is popular because it's very easy to configure for use over wireless mediums, which is not the case for EtherCAT or Ethernet IP, for example. There is less of a flexible feature set there. So Profinet is very popular and very commonly found in situations that might require PLC or industrial automation control over a wireless medium. So moving on, if we can quickly focus on the guide. So a few important things I want to highlight in this guide. We're not going to go through all of the details of these guides today, that otherwise this webinar will simply take too long, but we will highlight some very important points contained in these user guides. So the first thing is this user guide is available on the portals that I mentioned earlier, and this specific guide starts with a good context and background information on what Profinet is, where it came from, and what it's being used for today. So that's a lot of good information contained in that. In addition, we highlight some key terminology in this guide, which is quite important if you correspond with PLC engineers. You might be a network engineer corresponding with a PLC engineer. You need to speak the same language. So we highlight some specific terminology that you should use that will be familiar for PLC engineers. So a good way to educate yourself to be on the same page as they are. Just makes the conversation you have with them more conducive. The guide also describes how to calculate Profinet networking requirements. And it shows you, looking at these requirements, how to make some calculations and configure the protocol for usage over a wireless medium. There's various configuration options in the Profinet protocol that you can configure through the TIA portal software that allows you to optimize the protocol for use over a wireless medium. Now, something important to point out, if you look at this guide, a big part of this guide, a large part of this guide focuses on explaining Profinet, how it functions, and specific variables that might need to be configured, specific configuration variables that you need to configure in the Profinet protocol to make it function over a wireless network. And the reason for that is the majority of these field bus protocols were designed to function over a cabled network, copper or fiber network. And copper and fiber networks does not have the same medium constraints that you will have with any wireless medium. Most wireless mediums have to account for adaptive link and modulation and various technologies to keep the link up, but might sacrifice throughput, for example. So there's various things that you have to bring into consideration when you work with a wireless medium, and therefore it is important to optimize this protocol for transmission over wireless medium. That's the big focus here. But on default settings, you will not be able to make this work on a wireless medium because it's going to assume sub-millisecond latency requirements that you can only find on fiber, for example, not on any other wireless technology medium. So a big part of this guide will focus on configuring Profinet. Then right at the end, the guide will then also show you, even with this optimization, there is some specific kinetic mesh configuration and optimizations you can do to make sure that you have a rock solid mesh, constant low latency with very little potential disruption. So big focus on Profinet optimization, but also some instructions on making sure that kinetic mesh is suitable to carry the Profinet protocol. Now, we want to point to a few use cases. I mean, you might say, thank you, good information, but where do you actually use this? Show us some actual use cases. And the next 3 slides will do exactly that. We're going to focus on a few of them. Some of the partners on the call today has actually helped us with some of these use cases. So a shout out to some of you if you see some of your projects here. Each one of these actually might have multiple partners already seeing multiple successes. And one of the first ones is general plant process control. Now, plants, and this can be manufacturing plants, processing plants, chemical plants of various shapes and forms, makes extensive use of PLC and control and instrumentation technologies. I mean, it's no secret, PLCs and control instrumentation technologies is used heavily in industrial environments. And these modern PLC and CNI technologies use industrial Ethernet based on copper or fiber. So they have networks deployed in these environments, which is typically based on copper and fiber. Now, cable failure is something that is not uncommon. We've seen it quite a bit, and it's actually one of the things that drives the use case, the kinetic mesh use case in these environments. We've had a number of successes in my region, in Europe and in Africa, where we have situations where, for example, in smelter plants, cables or fiber would get damaged and processes would start, or you'd have downtime because of cable damage. So this is not an uncommon issue. And what we've seen partners do is by simply, very simply, just deploying breadcrumbs in parallel to this cabled infrastructure, literally just installing breadcrumbs at the endpoints and powering them on, you have a parallel mesh that's formed in parallel to this cabled infrastructure. And some of you might know, if you have breadcrumbs on the same cabled infrastructure, LAN infrastructure, you will get an APT group that gets formed. And the APT group is an instant automatic failover solution for this situation. So you'll have breadcrumbs just simply installed in parallel. You plug them in parallel to this network, and if a cable goes down, the kinetic mesh will take over and reroute to the closest fiber point or wireless route back to the core where that information needs to go. Now, along the same theme, partners also then simply install breadcrumbs in other areas in the same plant environment that's difficult to reach with fiber or copper, for example. And to elaborate on this, we've recently started seeing the really conducive small form factor of the cardinals. We've seen partners taking these cardinals, deploying them in small DIN rail mountable enclosures, allows control and instrumentation or PLC engineers to slot these cardinals in right next door to their PLCs on the same PLC panel, put on a small magnetic antenna, power it on, and you have a very easily, very cost-effective breadcrumb solution that you can deploy in the use case that we just discussed. So for those of you that want to look at doing something like this, please refer to the Cardinal Design Guide. It's already available on those portals that we mentioned earlier, and because there's some really important integration guidelines pertaining to powering, temperature monitoring, and aspects that you need to take into account designing a solution around the Cardinal. But the Cardinal is a pretty good solution because of the small form factor and the low power consumption. So moving on, we have at least 2 partners on the call today that's seen some successes in this environment. Electric conveyance systems, either electrified monorails or just general electric conveyance systems. It's typically an overhead rail that provides a path and power to a carrier structure that carries pallets or vehicle bodies or components in a production plant between different processes. And these carriers are very often typically controlled by an onboard PLC. That carrier structure there has an onboard PLC system. And in the majority of cases, what we've seen is these conveyance systems providers attempt to use Wi-Fi. There will be a Wi-Fi client device installed on that carrier, which they use for PLC wireless control. So there's a Profinet protocol that needs to communicate with a master controller to control these carriers that runs on the conveyance system. And what we've seen is this is a pretty common issue we've seen in these use cases where Wi-Fi roaming often falls short when these devices need to roam in this difficult metal-rich environment, high reflectivity environment. We often find that Wi-Fi roaming falls short and you have downtime. These machines will stop because they will have timeouts due to roaming issues. And what we've seen partners simply do is use something like the ES1 or Cardinals, install it on these devices, replace the existing Wi-Fi clients, and optimize the kinetic mesh for usage with a protocol like Profinet, and then you negate that Wi-Fi roaming issue. So a fairly solid use case that we've already seen some fairly good successes with. The last one I want to highlight is actually a very mature use case. We've had installations all the way back in 2016 that are still operational, and that's referring to stackers and reclaimers. And stackers and reclaimers is something that's almost indispensable at a large amount of ironworks, power plants, oil or coal terminals, and various mines. And these many of our multinational customers use the automated versions of these stackers and reclaimers. And the majority of these automated stackers and reclaimers actually use Profinet, a PLC system based on Profinet communication. And because of the size of these machines and these systems, they sometimes run over multiple hundreds of meters, a kilometer, kilometer and a half, sometimes 2 kilometer areas. It's something that's extremely difficult to do with Wi-Fi. You have to install multiple Wi-Fis, or you have to attempt to use some sort of a fixed wireless broadband point-to-point to point to multi-point system. But the size of these machines, the mobility of these machines, the turning action makes it a very, very good use case for kinetic mesh. And I mean, the distances is typically not an issue for us. And optimizing the mesh for use with Profinet means that this is a very, very solid use case. And we've seen a number of very good successes still in operation after almost 10 years. So this is a very, very good use case. So with all of that being said, that showed you our guidelines, or the guide available for kinetic mesh optimization in support of PLCs and Profinet, the Profinet protocol, and showed you some use cases just to illustrate where this is actually used. And that brings us to the first Q&A session.
Great. Thank you very much, Carl. Great job. You actually answered most of the questions that were asked in the previous session. I don't see any new questions in the question box now, but I do want to take the time to remind everyone and direct everyone to the chat icon at the bottom of the screen. If you move your mouse down to the bottom of the Zoom window, you'll see the dashboard come up, and you'll see the word chat down there. You can open that up, and if you have any questions, type it in there. If you have questions but you did not, I'm going to do a quick scan to see if I see anyone that took advantage of the raise hand icon, and I don't see anything right now. So I'm not going to belabor this. I'm going to turn it over to Stephen Griggs for the next section of our webinar.
Hello, everybody. So we're going to talk about, in the second section, we're going to talk about machine teleoperation, as well as full autonomy. And most importantly, we're going to talk about the resources that we're providing that will help you in your assessment, design, and implementation of these applications with a Rajant Kinetic Mesh. Now, this application, as we know, as most of us know, because I've seen several of you, you know, on the webinar, are very familiar with the implementation of various, you know, iterations of both tele-operation and full autonomy or automated haulage. So it's very, very important that, number one, you're familiar with the Rajant Kinetic Mesh, but number two, it's very, very important to make sure that you are inherently familiar with the application that you're attempting to implement. And we're gonna focus on those things during the second part of this webinar. And most importantly, again, we're going to take a look at we're gonna kind of present an overview of the help guide that we've provided in deploying some of these applications. So the guide is going to be available at both Rajant, both our partner portal and our support portal. So the partner portal is Rajant, channel.rajant.com, and then our support portal is going to be secure.rajant.com. Now, this guide does assume that the user has a very solid understanding of the fundamentals of deploying a Rajant Kinetic Mesh. It also will put a great emphasis on understanding the application requirements. Now, this is extremely important because when you start talking to customers and you start talking to end users and things like that, they're going to start throwing out figures like, we need a gig everywhere. We need 100% coverage. We need this, we need that, and so it's really important to understand how to break that down because, maybe they need a gig, but maybe that's aggregate. So, and that's, that's certainly, with all of the applications coming together at the APT master, that's certainly something that's potentially possible and something that we've seen. That's why we had to develop a faster and quicker slipstream. But understanding how that breaks down to per machine and how that's going to scale, and that's the other thing is understanding how this application scales. This is all going to translate to what your network requirements are going to end up being. So in the design process, because, and also, if I could digress just a minute, we're getting into, like, especially in mines, like they already have a Rajant network. So if they already have a Rajant network, now we're talking about adding an application into an already existing network that's already been deployed and already designed. So you're going to have to look at this application and understand how that's going to change the network requirements for what you currently have. So does that mean, adding more infrastructure, adding different models, things like that? So these are all things that you're going to need to take into consideration when considering these applications. So in the first section of the guide, we're going to provide these network requirement, and we've actually provided two network requirements, two separate network application requirements from two separate OEMs. So when you look at these network requirements, there's a specific instance or emphasis on understanding the latency, the jitter requirements, and also what throughput looks like. All the teleop and autonomy systems are going to give you a specific network. There's a minimum network spec that they're going to demand that these networks hit. So, for instance, this is the Caterpillar command for haulage. So for AHS, and as you can see here, they break it out they break it out in a very detailed fashion, so you can see what maximum latency is going to be, what your average latency should be, what your jitter should be. This is all very testable stuff. But here's the other thing: minimum throughput capability per machine. So they even break it down for you per machine. So now you have to start doing math, right? Because if I've got a fleet of 150 haul trucks, 6 megabits per for every 150 haul trucks, and that's also, you've got to look at your other application requirements as well, because you're not always just running that one single application on that truck. So so these are all things that you need to consider when you start selecting your models, and when you start selecting when you decide how you're going to implement your network. Understanding the application is absolutely paramount in deploying these things. And in this guide, we kind of break down some of these requirements, and then also how that could translate into your network design. So one of the things that you should also consider when we're talking about the deployment and implementation of the network, and in understanding the network requirements, is how does that look on your, as far as the kinetic mesh goes, how does that look on all of the different, with all of the different aspects of the kinetic mesh? Your RF environment is going to be extremely crucial. So understanding what that RF environment looks like, and then how does that translate to the throughput that you guys are that you're going to need. You need to understand what this is going to look like again for scalability. We want to make sure that we're making mesh connections at a capacity that will provide enough throughput and enough bandwidth for some of these applications. For instance, some of these automated drill applications, they don't like slow speeds. So sometimes data delivery, just getting the packet there, is not always enough. Some of these automated drill applications, they require a minimum bandwidth or a minimum amount of throughput. For some of the tele-operation, some of the tele-op applications, they've got a very stringent jitter requirement because of video. You've got operators that are trying to operate multiple dozers from a long way away, and that video can be subjective. Sometimes operators are comfortable with a little bit of jitter, and other operators are not. It just depends on the requirement and how tolerant that application could be for jitter, or how intolerant it is, and you have to design the network appropriately. Most importantly, though, you need to make sure that you're looking at your dedicated RF channels, and you're only using dedicated RF channels for that teleop or for that AHS. So you might need to be you might need to be deploying multiple meshes, or segregating your mesh depending on what the requirements are of these applications. Now, one of the other ways that you can get into segregating a bit is by using the mesh cluster ID. We've seen that in several instances. For instance, we had a customer running, I guess, upwards of 20 remote machines on one network. And with the way that this was deployed, it was a very hazardous work environment. So you had everything operating in the area had to be tele-remote. They weren't allowed to have human beings in the work area. Everything had to be tele-remote. So that made things interesting, because having that many in such a relatively close space meant that there were some complications as far as jitter goes, and APT and things like that. So we had to get into setting up mesh cluster ID, so we could set up certain machines that could only mesh with certain infrastructure, without having to reconfigure the entire frequency plan for the entire operation. So mesh cluster IDs are a good way to segregate your mesh a little bit. But it's very, very important to understand, to do the link budgets, to understand what your RF environment's going to look like and what it needs to be, especially for throughput purposes. So that's going to boil down to, what does my SNR look like? How big is my RSSI, et cetera, et cetera, et cetera. So additionally, when you're deploying, you want to make sure that your antenna placement on these machines and your antenna placement on your infrastructure is not hindering your efforts. So we want to make sure that, because these machines are mobile, right? So they're going to turn, they're going to do 360-degree turns, things like that. You have to be thinking about that when you're deploying your antennas. You can't be using panels on your mobile machines and expect them to connect 360 degrees. We want to make sure that we're using good antenna placement with clear line of sight. There are some application providers actually demand or require hop counts. So they want to make sure that you're at least specifically, one provider requires 2 hops from the machine to wired infrastructure. So when you're deploying, you need to you have to keep these things in mind. You need to make sure that when you're designing your network, your APT network is suitable to meet the network requirements of these providers. It's also very, very, very important to make sure that your backhaul links, whatever form that takes, whether that's putting directional antennas on a Ragent node and using that as your point to point, or using a third party point to point. We've had several instances in mining where we've used or customers have used third party point to points that were not configured for latency; they were configured for bandwidth optimization. So the problem is, with the mesh algorithm the way it was, we were actually meshing around the point to point because we could get packets from point A to point B faster through 5 or 6 hops than we could get it than they could get it through the point to point. So we've had to put in some features in BC Commander to kind of force that path. But the basic understanding, or basically understanding the requirement for your throughput, for your backhaul, and making sure that your point to point, point to multi-point, or if you're doing LTE, make sure that that backhaul link is suitable for making sure that you're meeting that throughput and bandwidth requirements. So in the guidelines, we do provide kind of a summary checklist or a priority checklist to make sure that you guys, as you're implementing and you're designing and you're thinking about how you're going to deploy this, make sure that you go through this checklist and make sure that you're hitting all of the points. You want to make sure that everything is coming into focus. There are things that are very easy to forget about, especially if you're running multiple applications and there are multiple. You've got the AHS, you've got the Tele-Op, you've got your survey applications, your high precision grading applications, you've got tire monitor, you've got tons of these applications that are all running at the same time. We want to make sure that we want to make sure that we're getting everybody the data that they need to run the business. Okay. So in conclusion, the beautiful thing about the Rajant Kinetic Mesh is it continuously optimizes itself. Now, there are things that we can certainly do to optimize for certain applications, but by its own very nature, the InstaMesh application or the InstaMesh protocol optimizes routing to make sure that we're delivering data as fast as possible to its desired location. Now, we are working very diligently, actually, in upcoming releases where we're going to have some, I guess, a set of preset configurations, some preset configurations that will get you very, very close for, depending on which application you're like, whether it's going to be AHS, Tele-Op, things like that. We're going to have a kind of some presets that if you're using this type of application, you can use this preset and it'll get you most of the way there. Every network is different. Every mine is different. We understand that, and so do you. So we can get you most of the way there, but at the end of the day, it's always, you're always going to need to turn a few knobs to do something a little bit better. But again, understanding the application's network performance criteria is absolutely critical. And then pairing that with the capabilities of your deployed Rajant Kinetic Mesh. We've seen these things work in so many locations. We got the Hitachi stuff working. Literally, we had a network deployed in the mine site. Hitachi came in and said, "Hey, can we run this over the network?" They tried it. It worked great. Then they started rolling it out, and the rollout and the scalability is what got them. They didn't plan for the scalability, so they had to go back and they had to drop back. They had to reconfigure. They had to deploy some more stuff, and then got it to scale. We've been running a very large tele-op operation on the Mississippi River with Caterpillar Command for Dozing. It's a very unique deployment in that they're putting these loaders inside ships, and they're running loaders inside the hull of a ship, and then they've got the operator a couple of miles away, able to see video clear enough so that they can clear out the hull of a ship with these iron ingots and things like that for the crane operator that's pulling all that stuff out of the belly of the ship. So we've done several trials where in Brazil and other places where they've deployed a Rajant network with teleop and full automation, and it's just worked very, very well. So that's pretty much all I've got for you. I think we're going to move now into a question and answer session. So I'll turn it over to Bernard.
Excellent. Thanks. Thank you very much, Stephen. Looks like a question just came in. Elliot, if you don't mind, please unmute yourself and feel free to ask your question.
Hi, can everybody hear me?
Yes.
Yeah.
Good morning, everybody. We had a question about what methodology does Rajant recommend to test throughput once the Kinetic Mesh is deployed. It is often asked by our clients in the compliance testing phase of a project to prove that the network can achieve the desired throughput. And in our experience, hyper throughput test results are not particularly repeatable, since the high demand of the test on the Rajant networks makes the cost of the link change, and therefore making consecutive tests or make the result really not repeatable from the same breadcrumb.
If I can jump in, and maybe Stephen, if you don't mind, because this is a specific thing. So Elliot, first, thank you for pointing that out, because I have a number of situations where customers, or maybe some partners that are not aware of this, try to use iPerf or the throughput test tool like a ping, and they don't realize the impact that a throughput test tool can have on a network. And in essence, what Elliot is pointing out is, if you perform a throughput test, you use our built-in throughput test tool, which is based on iPerf 3, on a network. Now, it can be a kinetic mesh or any fixed wireless link or whatever. If you try to use a throughput tool, that throughput tool is going to try to test the maximum of the network. It's going to try to test the limits of the network. And what happens is, if you have an intelligent network like Kinetic Mesh or InstaMesh that looks at a link degradation, a link latency, then it's going to affect InstaMesh. So if you saturate a link, InstaMesh is going to look at that and then attempt to load balance and reroute. So on a mobile network or an intelligent network, that's why he's mentioning that it might not be reproducible. Now, I'll answer that in a moment. Now, that's why you have to be really careful, and you have to think about and throughput testing is an application, and understanding what this application does is really important. So number one, good to point out that no, you should not run a throughput test on a production network. Something else that Elliot pointed out is, if it is in the testing phase of the project, the commissioning phase, benchmarking phase of the project, yes, good idea. That's the right time to do a benchmark, a test to look at the base network performance. Now, Elliot, the way to do that, number one, if you run a throughput test on default settings, it's going to test the limit. It's going to try and run a maximum throughput test and test the limit. And it's okay to do it once. It's okay to look at that, but that is not the correct way to test network conditions. Because there will never be an application of that network that will behave in the same way. The correct way to test network performance, to benchmark network performance for a sign-off, for example, is number one, when you start off and you understand what the customer application requirements are. If you build a wireless network, if you build any network, you build it according to a capacity requirement. We don't build networks for unlimited capacity. If I approach a new tender, approach a new opportunity, there has to be a clear statement of what the network requirement is going to be. If it's not there, it needs to be clarified, because networks have specific capacities. Wireless networks more so. The RF environment is a limited resource. You cannot build a network with just unlimited capacity. So what I'm trying to get at is, once you have a clear statement of that application network requirement. Give you a good example. We have, some of you might know, we have multiple projects with rail, for example, in the Middle East. And the application network requirement was, for example, in one of these for 20 megabits per second consistently off of a high-speed train to monitor 13 IP cameras. That was the statement. In the conclusion of the project, we ran the throughput test, not on default settings, but we tested for 20 megabits per second. You could specify that in the configuration, and you run a 20 megabits per second test run, and you can see if it meets the requirement. Now, a customer requirement can never be show me unlimited throughput or show me the maximum throughput. That is a very vague, a very undetermined statement. So you will test the network according to the application requirements, and that's a discipline that you need to communicate to a customer. It's not like an internet speed test that you run at home. These are industrial networks. They are built for specific applications, and you need to test based on the application network requirement. Does that answer the question, Elliot?
Yes, partly. We do understand that that you don't need to test unlimited throughput. As I was saying, is how can you show the customer that we have achieved the desired throughput? Let's say in one of our projects, it was 10 megabits per second in an open pit mine. In our experience, though, when you get in more limited coverage areas or where you're approaching the limit of the system, if the system will, let's say, start throttling you down, so it makes the results not repeatable and makes the results really it's a long time on site to do the test, since once you attain, you're close to the limit, you need to wait some time for the mesh to reassess the current.
So I get what you're saying,
traffic.
but that is a network design issue there, because if the requirement was to have 10 megabits per second everywhere, there shouldn't be a situation if you design the mesh to maintain the correct RSSI levels, to maintain the right connect rates, to maintain 10 megabits per second. The request cannot be, because if you're in a location or an area that has the correct connect rates and you run a 10 megabits per second throughput test, InstaMesh will handle it very easily, and the result will be repeatable. And as you rightly pointed out, if you get to a situation where you're on the edge, where you get to a lower connectivity rate area, then it's going to become interesting, because the rates might not be able to maintain that application requirement. So that points to a design or a scoping issue potentially.
Yeah, thank you, Carol. It's just as I was saying, I think what you design and what you get on the field is different. No LiDAR from an open pit mine is perfect. So when you get edge cases, I was wondering if you guys were recommending a way to kind of speed up the process and to not get in the situation where the mesh throttles you down to continue testing. But it seems like it's just an edge case that we need to be mindful of, and to when we get to those cases, just wait for the mesh to reassess the traffic before continuing testing.
You're always going to, in the deployment of the network too, the more APT ingress, again, I kind of briefly spoke about an instance where a certain vendor requires, a 2-hop. They have a 2-hop requirement. So if you do an InstaMesh trace, you should see from the truck from the truck a hop, and then to something, a piece of wired infrastructure. Be that a point-to-point LTE, something like this, something. So that's going to play a big part in making sure that you have more consistent throughput. But again, this is a mobile network. Your devices are mobile. You're going to have obstructions and things like that just by the nature of the beast. So you're always going to have some kind of an edge case, as you put it. There's always going to be that. It's just something you can't get away from, and the applications are usually expecting that as well. I mean, you have when you go to the test grounds and you start testing for the applications, they're usually fairly to begin with, they're fairly simple. Everything's wide open, point line of sight, all that kind of stuff. And then once they determine that it works, under good conditions, they start trying to figure out what it looks like when things are not so optimal. And that's really kind of the important thing, the importance of testing under those conditions is understanding how that application is going to work under less than optimal conditions. Does that make sense?
Thank you. Yep. Thank you, Stephen. Thank you, Carl.
Yes, sir.
Great. Thank you for your question, Elliot, and for the answers, Stephen and Carl. We've got two more questions here that we want to get to. One from Carl Wayneth. If you could unmute yourself and ask your question, that'd be greatly appreciated.
Sure. Am I coming through okay?
Yes, sir.
Yes, Carl.
Yeah, my question was when Steve was talking through his portion of the webinar here today, mentioned some preset features coming in a future release of firmware. Is there kind of a general availability ETA on when some of those things might be available?
Yes, it's funny, Carl. As soon as I saw your question, I've been feverishly texting with some of our development people to try and get you an answer.
Okay.
But I'm thinking, Q4-ish. At least I'm hoping Q4-ish, but maybe sooner. So there are different vendors have different requirements. I think we're going to do this in a couple of different phases. Like I think first we're going to work on some of the specific requirements for CAT, because that seems to be where a lot of people are going. So I think we're going to be focusing on that, and the requirements are very specific. So that's good. So that's something that we can definitely program to. Some of the other vendors, we might have some other presets for them, but I'm hoping that we're shooting for Q4 or sooner. But that's I can't put my hand on a stack of Bibles and swear to it.
Sure. Okay. Thank you.
Yes, sir.
Thanks a lot. Ed Gibson, could you please unmute and ask your question, please?
Yeah, hi everyone. Thank you for the presentation. I just thought that Stephen's use case there of the loader in the hull of a ship on the Mississippi was good. We're a new partner, and I'm trying to identify some various use cases and opportunities, and just wonder if you have any other similar use cases that you could tell us about.
So without getting into too many specifics due to NDAs.
Sure.
There are several construction instances. There's also construction. So so right now there's heavy construction, like roads, highways, interstates.
Steve, I think we might have an internal PowerPoint deck that our sales team is using for use cases in construction, ports, mining, etc. for Tele-Open. I think there's an internal PowerPoint. So, I mean, you get the details, and maybe it's something we can share.
Yeah. Also, they're in ports. They're doing a lot of tele-remote and autonomy in ports. So for the reach stackers and things like that, we're also seeing a lot of autonomy in warehousing. So even into robotics. So there are really a lot of use cases, but basically anything that's mobile, anything that's I guess repeatable, something that's where somebody driving back and forth and back and forth and back and forth, or teleop, tele-remote. Tons of those opportunities in several different markets. So there are, I know we've got some videos on some of that stuff as well. There's a lot of, they're actually doing a lot of automation in rail nowadays too. So there are lots of instances of at least semi-autonomy or autonomy in most markets now.
Right. Okay. Well, thank you very much.
Thanks, guys. So I said we had two questions, but now we have two more. So Piers, can you go ahead and unmute and share your questions?
Yeah, hi there, guys. Thanks for the interesting presentation. I currently have, or am managing a network, quite a considerably large network from what we're used to, which has several different applications that require very different performance criteria in terms of throughput, latency, and jitter, etc. And I've been going off the fact that if if an application requires low latency and high capacity, and then there's another permutation of that, then I've just been going for the best results that we can do to cover all bases. But do you have any standard practices in terms of how to actually separate these networks or the traffic over these networks whilst addressing their specific requirements in terms of the modulation rates and the Instagram settings, so that we might be able to actually address these applications simultaneously over the same network, or would you completely separate the network?
Some application providers, some OEMs require that the network is segregated for their particular application. And that's because, because of safety concerns. So, for example, some of the one of the providers that provides full autonomy, so the full autonomous haul trucks, that is it's a requirement that network only does that application, because a 400-ton haul truck going wonky is a catastrophe, right? So they want to make sure that everything that could go wrong is not because of poor communications. So there are some providers that and that's listed in the network requirements, generally speaking, that for their application they require a fully segregated network. Now, there are others where you can do teleop or tele-remote plus, high precision grading plus, et cetera, et cetera, et cetera. In that case, yes, you're definitely looking at instituting VLANs. You're instituting, and then you can look at what your frequency plan looks like. It's going to depend on, what your network requirements are and what you're able to provide with your given infrastructure. You may have to provide more infrastructure, more APTs, more point to multipoint, that kind of thing. Cluster IDs are really good if you have certain nodes that are that you want tied to specific areas, like in the case in Brazil, they had a collection of several machines that were all trying to join and be part of like this one APT group. And so that became kind of problematic and caused a lot of jitter and things like that. So they had to spread the love a little bit, right? And make sure everybody was kind of more spread out as far as their connections go, and make sure that everybody's processors were equally load balancing. Does that help, Pierce?
No, that's extremely interesting. Yeah, we've got up to 25 ABT groups in this network alone at the moment,
Wow.
in places that you wouldn't expect it. And I have often wondered about separating those APT groups to get the best out of every breadcrumb rather than siphoning it all through one. But I think as a larger conversation, I know there's more questions to answer, but that's very helpful. So thank you.
Well, aggregate throughput is also something you have to consider. So you have to make sure that your whatever you have on the back end, whether it's a slipstream or the 10G slipstream.
Yeah, we're in talks with them about the slipstream rather than separating the APT groups to make separate networks at the moment, which I think.
So you're doing multiple masters and things like that.
Yeah, precisely. Yeah, but thank you. That's really how I'll follow up with anything offline after this session. I know there's people who want to ask other questions, but that's really helpful, Stephen. Thank you.
Yes, sir.
Cheers, man.
Okay, I know we are at time right now, but there's one last question here from, I think this is pronounced Thean.
So this is from our customer Tian Snevenhuizen. So Tian says, I read that's a request we've had from multiple partners. So Tian's question is whether we can virtualize a slipstream as a cloud platform or a virtual platform. So a few things. If you look at the core requirements of a slipstream, and the actual function of a slipstream, it becomes really difficult to do. Can we potentially develop a software instance of a breadcrumb that might function in a limited format as a slipstream. That might be something we can look at. It's being considered, and we can report if it actually makes the roadmap. But if you look at the capacity requirements for the slipstream and the slipstream XG, for example, putting that in a virtualized environment becomes very, very difficult. There's more to it than just a Unix, Linux-based system being virtualized. There's a lot more going on in the background that requires direct access to hardware resources that you can't always get with a virtualized instance. But there is potentially a virtualized instance being considered, but it won't be on the same performance level as the current slipstreams.
Thank you very much, Carl. So in closing, as Stephen and Carl mentioned, the guides can be found in the support portal and the partner portal. I like to point out that you can get to both of those portals from Rajant.com. In the top right, you'll see tech support. That'll take you to the support portal. Right next to that, you'll see partner portal, and amazingly, that'll take you to the partner portal. If you need access to either of those sites, reach out to channel@rajant.com or reach out to your sales rep or one of the SEs, and we'll get you squared away. I'll also point out really quickly that in the partner portal, those guides are found under resources and then in the tech notes from the field section. In the support portal, if you go to documentation, they're the first two documents in the list. So I want to take some time to just say thank you to everyone for spending this hour with us. Thanks, Stephen. Thanks, Carl, for all the information that you shared. Thanks to everyone for your questions and your attention. And lastly, I want to thank Gizzy and the marketing team for all the work that you guys put in behind the scenes to make this happen. Everyone have a great day, a great afternoon, a great evening. And once again, thank you.